you want to do something that's kind of cringy. Now, I know cringe culture is dead, but I think this is kind of a cringy limit to try to do analytically, essentially because we're going to be using the thing that this limit yields to evaluate this limit. I'm talking about this limit. If you don't know what this limit is, then this famous limit is, then it's okay. Let's just figure it out like we didn't even know what this was. So I'm going to let y equal to 1 plus 1 over n to the n. Take the natural log of both sides. So we get ln of y equals to n times the natural log of 1 plus 1 over n. Okay? And then we see here that y is just the same as e to the n times ln of 1 plus 1 over n. And so we do the limit as n approaches infinity of y. That'll be the same as the limit as n approaches infinity of e to the n times ln of 1 plus 1 over n. Right? And so then we can rewrite this as, right, limit as n approaches infinity of this guy right here, which we're trying to find, which is 1, because that's the same as y. We set that equal to y, 1 plus 1 over n to the n. That's just going to be e to the, and using properties of limits, we can say this is e to the limit as n approaches infinity of n times ln of 1 plus 1 over n. And so now let's do a tiny side problem here. Let's actually evaluate this limit. So the limit, I'll leave a little space here, limit as n approaches infinity of n times ln of 1 plus 1 over n. Okay, this will be some indeterminate form. Okay, so let's divide both sides by, or the numerator and the denominator, by 1 over n. So cancel, and we get the limit as n approaches infinity of ln of 1 plus 1 over n over 1 over n. And here we can use L'Hopital's rule, because this will be 0 over 0. And so then this will be the same as the limit as n approaches infinity of 1 over, because derivative of the natural log of 1 over 1 plus n is 1 over 1 plus 1 over n times the derivative of 1 plus 1 over n, which is just negative 1 over n squared. And then this will be over the derivative of 1 over n, which is also negative 1 over n squared. And then these two will cancel, and then we get the limit as n approaches infinity of 1 over 1 plus 1 over n. And then if we quote-unquote plug in infinity here, we'll get 1 over 1 plus 1 over infinity, which is just 0. So we get 1 over 1, which is 1. Now, this is not our final answer here, because this 1 is the answer to this limit right here. And so then this will equal to e to the first, which is e. That's right, ladies and gentlemen. This is the limit, right? The limit as n approaches infinity of 1 plus 1 over n to the n, right? 1 plus 1 over n to the n. This just equals e. This is the famous limit that yields e. And so if you didn't know that, well, you probably learned this analytic technique of evaluating limits before. This really shows just how we tend to solve problems blindly using a procedure that we were taught to use, instead of recognizing that, wait, this is a limit that actually yields one of the most important constants numbers in history. This is Euler's number. This is E. A lot of things would not be possible without E. Continuous interest. There are a lot of demography applications. Watch my, I had a video, it was on Pi Day last year, 2024. It was giving a history of E, not pi, because I think that arguably E is much more significant than pi. So yeah, just that is a cringe limit.